ALCAN Systems is a startup working on cost-effective phased arrays based on liquid crystal technology.
I mean, in the past, when I was a kid, where we had the mobile phones with the antennas kind of flipping up and down, nowadays most antennas are kind of hidden, if you will, within the electronics.
So in commercial world or consumer world, only thing you can get really at cheap prices is a dish or a rod antenna.
What we are targeting is these constellations, satellite constellations for broadband internet through satellites, right? And these satellites are zipping over the sky. You know, they rise and set within a matter of minutes. That's when you start to need these electronically steerable antennas, or smart antennas as we call them.
There are now ways to make those big bulky antennas into something flat and also conform to some surfaces and even transparent.
If you ask anyone in the antenna industry, when you say a phased array antenna, one of the first things they will say is how much power does it consume, and then how much does it cost? And usually that number would be in the tens of thousands of dollars, if not more, actually. What we can do is we can build phased array antennas at low, sort of consumer level cost, and that consume almost no power.
We sandwich liquid crystal between two glass layers. It's the same technology which the LCD uses, and we actually make our antennas on the same production lines which the LCD televisions are already using.
We are a startup company. You know, as startups, you know, you are limited in time, you're limited in money, you're limited in human resources, right? Let's say we have a set of product specs on hand, and we have some ideas, right? We start simulating right away with SIMULIA products.
There are no more simple antennas which you can design using just pen and paper or simple equations. They are really a complex system, and to achieve that you need not just simulations but extensive simulations.
From these concept design to detailed design, and now prototyping, and then you get measurements, and then you want to compare those measurements to simulation. Those two never agree, especially on the first try, right? This difference could be small, it could be big, you know, but there's usually some difference. And then once you understand that, you're going back to your simulation tools again and starting and improving, and another prototyping. Being able to work with CST has been awesome.
CST has all these solvers which you can use at different levels, at component level or even at system level, and that's, I think, really great.
You have to, as an engineer, you have to have confidence in what you are simulating, in your tools, in your in the results you get from these tools, right? And be able to say, okay, if I got this result, that means this is a dead end, or that means this is really promising, right? So you have to have that confidence, and we have that confidence in SIMULIA tools, and especially you know, CST.
I love simulations because it lets you see the dancing fields, the invisible, actually, the flow of energy.
I love CST because it's flexible, and I love CST because it's never let me down.